Thanks for attending a session on Thursday afternoon, which is the hardest part of Tech Ed. Fortunately, they moved the party to the night of the last day of Tech Ed. A couple years ago, I did a session on BizTalk server. What city were we in that year? I can't remember. I think it was Boston. And they had the party Wednesday night, and my session was 8 o'clock Thursday morning. And we actually had 200 people in the room. I was shocked. But anyway, welcome to COS 210. This is 10 must-have tools for Windows Azure. I'm Brian Prince. I'm a Windows Azure evangelist. I work with customers, with user groups, with community and that sort of thing, and help them understand cloud computing, how they can maybe leverage that in their organization, in their enterprise. I go all over the US and occasionally around the world to do this. I am here to answer your questions on cloud computing and Windows Azure, so feel free to email me or send me a Twitter or something like that, and I'm happy to do what I can to help you out. I do travel 260 some odd nights a year, so I may not respond immediately to your email. It takes time to get through airports and hotels and all of that sort of thing to finally start working on an email. But we're here to talk about tools. We're here to talk about tools that are going to make your job easier, make you more productive, and I think we all need tools. Otherwise, we'd all still be writing ASCII directly into some sort of low-level assembler, right? And it's about being more productive. It's about only writing the code that only you can write. I give that guidance to every developer I talk to, because it's very common that an enterprise developer specifically will want to build everything in the whole stack. The security infrastructure, the management infrastructure, the logging infrastructure, the exception management, all of that stuff. Persistence, for example. And you should really focus on only writing the code that only you can write. For example, if you work for a healthcare company, there are certain things you know about the intellectual property and capital of that company, and you need to leverage that to your best capability to deliver value to that business. All the other stuff, anyone can write and Hibernate. Anyone can write some event logging system. Anyone can write those sort of things, and you should be leveraging tools that are available either commercially or open source or what have you in your product so that you're only writing the code that only you can write. That's how you can compete in this marketplace with all of the other developers on the planet. So what we're going to do is look at some tools that are available for Windows Azure so that you're not writing those tools. Now, how many of you are already using Windows Azure? Good. If you aren't using Windows Azure yet, on the back table I left some postcards that will give you a 30-day Windows Azure Pass so you can use it for free. If you have MSDN, you can you have free time in Windows Azure with your MSDN subscription. You need to activate those benefits. Depending on your level of MSDN, you'll get a different amount of benefits. If you have questions about that, I'd be happy to show you how to do that. So our goals in this session are, I'm going to assume that you are vaguely familiar with the capabilities of Windows Azure. We're going to focus a lot on the compute side and the storage side of Azure. And we're going to look at tools that are going to have a material impact on what you're doing. And some of these are going to be commercial. They're generally fairly inexpensive if they are commercial. Or they might be open source. Now, most of the open source projects we're going to look at are something that I probably wouldn't launch as is into my production environment. I would probably take that package and bring it up a notch. So what I encourage you to do is to be a good open source citizen and contribute back to that project any extra features or capabilities that you add to that package. Now, I'm lying. There's actually more than 10 tools we're going to talk about, but I thought 10 was a good number to throw in the title. And I thought, well, worst case, if I'm prepping for this session, I can't find 10 tools, I can just say it's binary and it's actually just 2 tools, and then we could just cover 2 tools. But we actually have more than 10. Don't have time to demo them all, so I'll probably do a little hand waving from time to time and explain what it does and where you can get it. And we're only going to look at tools that come from outside of Microsoft or that aren't official Microsoft products. We ship a lot of stuff. We ship the visual tools for Windows Azure. We have tools for PHP developers and Java developers and that sort of thing. We have lots of other pieces of sample code and so on that are shipped in the Windows Azure Platform Training Kit. So I don't want to cover those things. Those things get plenty of enough coverage and presence as well. Now, these tools probably fall into a couple categories, right? We're going to look at tools that are going to help us manage our runtime environment. Just because we're moving to the cloud doesn't mean there isn't any room for IT pros anymore. Is there any IT pros in the audience? Are you all developers? All right, so we still need IT pros to help us manage and allocate resources and make sure we have the right resources allocated to Azure at the right time. So, for example, do I need 10 servers right now, or are 7 enough? And IT pros are the ones that have that experience and skill set to kind of manage that infrastructure and make sure we have the right stuff at the right time. So we'll have some tools around that. We'll have some tools around debugging that'll help you work with debugging. And the ones I'm going to show you, one of them actually apply to normal web app development, so you might already be using it. It's the last one we're going to look at, just to make you sit on the edge of your seat here. And we'll look at some things that'll help with deployment. Now, Windows Azure has a great deployment story, whether I can deploy through Visual Studio, whether I can deploy through Web Deploy, I can deploy at the command line and those sort of things, and I can do VIP swaps and rolling upgrades and so on. But generally, I don't want to do those by hand. I want to script those out and automate those. We're going to look at some tools that'll help you do that. So the first one we're going to look at will cover probably the first question I get about cloud computing, and that question is, does Windows Azure auto-scale my application for me? So I have an application, it's a web application, I've deployed it. Maybe there's some front-end servers like the web role, and I have some back-end servers running on a worker role. Maybe there are some queues involved in that sort of thing. And some people want Windows Azure to scale that application up and down automatically for them. And today we don't do that. Today we don't scale for you, and there's a couple reasons for that. One, cloud computing is very new, and there is, especially as you're trying to get your company to adopt it, adopt cloud computing, a lot of people have a lot of trust issues with cloud computing because it's not under their control directly, they think. And so we don't want to worry them anymore with a fox in the hen house scenario, right? If I'm scaling your app for me and I need my stock price to hit 27 bucks, I might more aggressively scale your app than you want. No, we wouldn't do that, but people might think that's going on. We want to avoid that perception. The second is every application scales for different reasons. Some apps scale for memory pressure. Some apps scale for CPU pressure. Some I want to monitor the active number of connected simultaneous users to my web server. Maybe it's more of a full-time connection versus a stateless web connection. So there are a lot of reasons why and when I might scale my app. And I would strongly recommend that you run your app under different levels of load. Determine what your scale unit is for that application. So for example, my web app running on a small instance, which is one CPU with about 2 gigs of RAM, I can support 1,000 simultaneous users per web role instance. All right, that's my scale unit. Now I know as I monitor my traffic, I'm going to scale about 1 instance per 1,000 users. And we'll use the Diagnostics Management API to gather all of that data. And that management API we give to you, it's through REST. I can change that code, change what I'm gathering through diagnostics in my code, in my application, or from outside my application on my laptop or wherever. And I'm going to gather any amount of diagnostics data I want that I'm used to getting from Windows Server. So I can get event logs, I can get IS logs, I can get FREB logs, I can get crash dumps. Never, obviously, from my code, but I'm sure you have colleagues where you have to get crash dumps from them. I can get performance monitor counters, so my CPU levels and my memory levels and that sort of thing. I can get any file off of that instance that I want. Maybe I'm using Log4net for logging and I want to pick up the log files that Log4net is generating. So I'm going to gather all of that data and I'm going to analyze that and I'm going to make a scale decision up or down. A lot of your cost savings comes from knowing when to scale down. And then I'm going to use that data, that decision, and use the Service Management API to make changes in my Windows Azure environment to add and remove servers, provision new capabilities, and so on. So I'm going to start when I first have a fresh new application, and I might build an app that shows me the diagnostic data, or maybe leverage one of these tools I'm going to show you to monitor that diagnostic data and use a tool to manually make those scale decisions. But I'm going to learn how my app inhales and exhales under load. How does it behave when I cross the 1,000 user mark and the 10,000 user mark and the 100,000 user mark? Whatever those loads are in your typical environment. and I'm eventually going to want to have something that auto-scales for me. And the best one out there, at least that I've used, is called Azure Watch from azurewatch.net. It's actually a company called Paraleaf. They're a small ISV out of Chicago. And this is an app that runs on your desktop. You wire it up to your environment with Windows Azure. You have some configuration and some rules, and it will monitor then. It runs as a service on your desktop. The UI you load when you want to change things. And it will monitor your Azure environment, gathering that diagnostics data, executing those rules, and implementing the decisions you want it to make. So for example, if my average CPU across all of my servers is below 50%, scaled down by one server per hour, no more often than once an hour. So I can put that in there. Or I can say, hey, if I get more than 10,000 items in a queue that I'm using between my front end and my back end, don't do anything, just send me an email. And I will make a manual decision. You can put in boundaries. Don't create more than 10 servers, right? We don't want any auto-scaling code, let alone something like Azure Watch, to go out of control, turn into Skynet, and create 400 servers for me over the weekend. I'm going to come in on Monday morning and just have a big bill. So you can put in boundaries, you can put in cooldown periods, and I think once you download it and use it, you'll get a sense for how complex the auto-scaling equation really is, and you'll appreciate getting a tool. Now, Azure Watch is interesting in how they sell it. They sell it like we do Windows Azure. They sell it by how much of it you use. So they charge about a penny per server per hour to monitor your environment. And I think that's a very fair price for the value that's given compared to how expensive it would be for you to build something like this yourself. So in my environment, I have a web application running. And let me minimize some of this stuff. I'm going to bring up Azure Watch now. Now they have it's a very high-res app, so I'm going to be zooming in and out a lot. On the left, we have a big navigation tree that shows you my Azure environment, what apps I have released into production. So the app we're going to be working on is TINA 2011. TINA is Tech Ed North America. TINA MT is for the multi-tenant app we'll be doing later. And so I can do some configuration in here and do all of that. And what it's doing is it's monitoring my instances over here. So it shows all my servers and says they're all ready to go and that they're running. And here in the middle, I can say, we're going to look at our worker roles. So I have one app with I'll show you here. I have one web role running. You can see current instance count 1. And it scaled actually at 10 p.m. last night, 10:48 p.m., from two instances to one instance. Because there was no load on my web servers, so it scaled down. Now be careful when you scale to one server, one instance, you do not get our SLA in Windows Azure. You have to have 2 or more instances for SLA. So this is for demo purposes, if you will. Although I know some companies that run one instance because they don't care if it's down for the 10 to 20 minutes it'll take the Fabric controller to repair the server. On our back end, the worker role that we have, I have 4 running, 4 instances of the server running. And what it is it's picking up messages out of a queue and processing them. It's doing something very sophisticated with that message. It's writing it out to the trace log, right? I'm sure all of your applications are as sophisticated as that. And it's just sitting there cranking on this queue. And I have a very sophisticated console app here. These are the messages that I am producing. It's cranking on them right now. We're up to almost 34,000 messages, and it's just sending messages into that queue from my laptop just to keep these servers busy to build some sort of CPU load on them. So what I did before the session, if I now come in here, looking at these 4 servers, I can look at a snapshot in time when the last time this screen was refreshed. And let's look at the processor total. So this is the total processor across all of my instances. And you can see last night as I was warming up for my demo, I was putting a huge load on that. So I was using about 80% of my CPU. And now I'm not putting much load on it at all, so it's much lower. Now I have a scale down rule in effect, but I've hard-coded something into it to keep the rule from kicking in before I'm ready to show you how it works. I didn't want it to scale down, and then it would be really boring to watch it scale up, because that takes 20 minutes, right? So I'm going to show you how to do this first. So I'm going to open up my TINA 2011. I have my web role and my worker roles here. We're going to look on our worker roles. And I'm just going to load up the rules here. And they come out of the box. Excuse me, the screen is whacking out a little bit. It comes out of the box with these top 3 rules automatically. If any of these instances become unresponsive, and that's an actual status that roles can have, healthy, unresponsive, and so on. And currently, it's configured to just send me an email. If I scroll over here, it'll say, if something is unresponsive and I don't have enough that are considered ready, this will, I'm sorry, it's set to scale up by 1 instance. If I go back over, if the average CPU time is above 70% for 60 minutes, then you can see we're going to scale up by 1 instance. If the CPU time is below 50% for the last 60 minutes, then scale down by 1 instance. And then if the application queue average depth, so I can actually monitor the depth of the queue that's sitting between the web roles and the worker roles, and do a dot count on that, measure that depth, and then decide based on the depth of that queue if I want to spin up or spin down servers. If that queue is getting very deep, I probably need more worker roles, more worker instances to process that queue. And if it's very shallow, I have too many worker instances, and I'll turn some of those off. And this rule will handle that for me. Now, in here, part of that low CPU that I didn't show you is if my average CPU time is below 50 and if 1 equals 0. So I've hard-coded the rule to not scale down, right? If 1 ever equals 0 and this rule triggers, you should go get your shotgun and 2 weeks of food and water and go hide in your basement with your family, because we got bigger problems than the scale of your web app. But so I'm going to take this rule out now and make it a normal rule. And so I'm just going to double-click on that, and I can get in names, and I can put in all the expression words in here that I want. And I'm going to make it purely monitor the CPU. I'm going to hit OK. Now, I've only changed my configuration. I haven't pushed that up yet, if you will. So I'm going to first go in and stop my little simple load tool here and hit Publish Changes. Yes, we're OK. Please publish those changes. OK, that's not normal. Let's try that again. OK, pretend you didn't see that. Let's rescan. I turned some services off, and maybe it's mad about that. What it's going to do is use the Service Management API, hit my Azure subscription, find out what all of my deployed instances are, and download that configuration. It'll only take a second. Here we go. Now I should be able to publish. When we publish, it does keep your configuration data, not your credentials to connect to the cloud, but your configuration data on the Azure Watch servers so that you can have your settings stored in the cloud as well so you don't lose them in case the laptop disappears or something like that. So we have done that already. Now we can go back to our major dashboard here, and this will take a few minutes for it to kick in as it's monitoring. And this dashboard, you do have to refresh. They didn't want to keep hammering the service. But it won't take very long for it to kick in and start dialing down the service. Any questions on auto-scaling so far? Yes? So the question is, if I need to scale up with a tool, Azure Watch help me deploy the web role. What happens is it will detect that there needs a scale-up scenario, right? Maybe it's too busy. It will send a command to the Service Management API, hey, I need one more instance. And the Fabric controller kicks into gear, finds a new instance, starts it up, deploys your code that it already has in the vault. When you first did your deployment, we kept a copy of that code. And it will deploy that code to that instance, wait for it to stabilize, enroll it in the load balancer, and you're all set. This is, out of the box. So now when you, just Windows Azure in general, when you start a new instance, it can take anywhere from 10 to 20 minutes to come online because we have to allocate hardware, configure the network, right, because it's in a VLAN, configure firewalls and load balancers and DNS, And we have a lot of unicorns, but they're very busy doing all of this stuff for you automatically, right? Did you have a question up front?
I was going to say, one of the other sessions, they were saying that's actually dropped a lot in the last couple.
It has. It's been getting faster and faster, and
That's like 2 to 5 minutes.
I haven't seen 2 to 5 minutes. Was it a marketing person? I'm joking. I'm joking. So I know they are working on improvements to make it much faster, and that is because we're improving the automation, in that IT infrastructure that we have. I was doing a demo earlier today, and I said, all right, we're doing a workshop. Some of you were in it, and we're going to hit F5. We're going to deploy our code. That'll take about 20 minutes, and 2 minutes later, it was ready. So I was very shocked to see that. So let's see here if we've dropped any instance counts. So if in the middle here, I can click number of instances. You see last night, or this morning, I scaled up to 4. We're still at 4. Let me hit refresh here. Now, the demo for Azure Watch, when you download it, they give you automatically 500 hours of monitoring for free as part of a demo. And then you can choose how you want to pay it. You can buy hours ahead of time at a big discount. You can pay just the 1.3. So I can see here this one is in an initializing state at roll 1. So it should be dropping soon. I don't want to make you, we'll come back to it later. Now you can choose to run this in Azure Watch's environment instead of on your desktop if you want. That way you don't have to worry about if you have any local infrastructure at risk of going down, so that you're always monitoring this. And you can, again, maybe not make it do scale decisions, have it send you emails and say, you know what, we detected that your queue is stalling. You may want to go do something about that. So you can definitely configure to do that sort of thing. We just did that demo. Now there is, if you look, we're going to talk about Locad in a minute. There's a company I think they're out of France, called Locad, and they have deployed to CodePlex an open source monitoring auto-scaling tool. It's not nearly as sophisticated as Azure Watch, but you might want to look at it. And back to that, only write the code that only you can write. Imagine how long it would take you to write something like Azure Watch and make sure that you did it properly, right? The average fully encumbered developer in the US costs about $100 an hour. And if I buy a tool, that costs me a penny per hour per server to write. There's a lot of monitored servers and hours before I even get to that $100 for the hour, right? So you're going to get all excited about cloud computing at TechEd. You're going to go home, and all of us likely, I don't see any here in the audience, all of us likely at home have a pointy-haired boss. And you're going to go talk to that boss about cloud computing and how it's all about cloud computing, and cloud computing is awesome. And if we're not doing it, we're back in the 80s. And he's going to go explain this cloud computing to me. And the only thing they care about is the return on investment, which is the real only reason we should do anything in IT. You don't deploy a brand new shiny Silverlight 5 app with spinning donuts and logos on fire for fun. Well, we would like to, but that's not why the business hires us. The business hires us to have some sort of impact, either to reduce costs, to improve revenue or some degree, to add some sort of capability that our competitors don't have. So we want to try to calculate that return on investment. And generally, when we're thinking about an app we're going to do in the cloud, because you pay for what you use, there's no fixed sunk cost like a traditional environment. People worry about, what's this really going to cost me when I'm running it in the cloud? So our friends at Nudesic, this is actually a little while ago, they wrote an app called the Azure ROI Calculator. Now we have our own, but this one is far simpler. I'll show you both of them. And you can get to it at azureroi.cloudapp.net. It's a very simple, they've made it very, very simple to go through, calculate what the application that you're thinking of will cost. There's a tab there, so you can not only calculate what the running cost will be, but what the migration cost might be. So I'm going to Alt-Tab over to that. And so we're going to, they have a few loadouts here. So let's say we're going to do a large application. We'll do a medium. How's that? So we expect that we're going to run 2 servers full-time. They're going to be medium size, let's say. So that's going to cost me 24 cents an hour. So a full year of that's going to be $4,200. Now remember that this tool, being very simple, doesn't easily take into account that I might run 10 servers during the day and 2 servers at night. Right? If no one's going to be using my app at night, I should spin down as much as possible. I can script that. I can schedule that. I can hire like someone to sit there and just do that in the tool for me manually, perhaps. But that's where some of the big cost savings come from. We have customers that launch tons of servers during the day, and at night they shut them all off and go home because they don't need them at night at all. So take that into account when you average this out. They're saying 2 full-time servers. So that would be 48 hours per day of compute time. From a database is what they mean is SQL Azure. So one 10-gig database in SQL Azure costs you $100 per month. So that's going to cost them $1,200 per year. Storage, we charge storage by the amount of storage you're using, the amount of bandwidth that you're using, and the number of transactions that we're doing against that storage. So here they're saying they're going to use 100 gigs of storage. That's at 15 cents per gig. Notice I can change the rate there because if I'm buying some SKUs that we have available, you can actually buy a commitment of storage and get a discount off of that 15 cents. So that's going to cost us to store 100 gigs of data, $180. Now that is cheaper than I think any one of your SANs at work. Right? Anyone have a SAN at work? Right? They come with a shovel. Did you know that? So you can shovel money into them. That makes it easier. And usually when customers, they get excited, they deploy. SANs are a very important part of infrastructure, don't get me wrong. But after about a year of using your SAN, you will decide that you shouldn't put everything in the SAN because it's too expensive and you start coming out with tiered SLA storage environments. Has anyone done that in their environment? Yeah. If you all had your SANs longer than a year? Yep. Is your shovel break? No. So there is definitely a certain category of data that is much cheaper to store in Windows Azure, right? And our storage is in 3 replicas, blah, 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 blah. Now, these storage transactions confuse the heck out of a lot of people. Every time, to simplify it, every time I read or write to Windows Azure storage, not SQL Azure, but blobs, queues, tables, and drives, that is an operation. Every 10,000 operations costs you a penny. Usually, in most scenarios, that operational transaction cost on storage will be a rounding error in your estimate. You can see here I'm going to spend $180 a year on storage and 12 cents on transactions. Now there are some scenarios I've looked at where it's the opposite, where the transaction is the real cost, but that represents your load on the storage system that you're representing. We'll get to the bandwidth charges in a minute. And then CDN, if we're going to use the CDN, we're going to say that we're going to have $50. And actually, as you can see, well, they have a bug here, actually. CDN actually now is charged, basically you're paying a little bit more for bandwidth. So you're going to have your item in blob storage, you're going to pay your 15 cents a month for that. The bandwidth that you use from blob storage to the CDN cache server, we have 24 of those around the world, and then from that cache server to your user, you're going to be paying for that bandwidth. And that's how we pay for CDN. It's the same infrastructure that we use for Windows updates and those sort of things. And then down here in bandwidth, so any bandwidth into or out of the data center, you're going to pay for. 10 cents per gig inbound and 15 cents per gig outbound. So here they're going to use about $30 or so of bandwidth a year for what they're estimating. I would basically, if it's an existing app you're migrating, I would talk to your infrastructure team, monitor the bandwidth that's going in and out of that application server, and you'll get a good sense of what your bandwidth charges are going to be. What we charge for bandwidth is actually fairly competitive in the marketplace. You're paying for bandwidth in one place or another. Even if you're hosting the database, the application in your own data center, you're paying for that bandwidth eventually. Now remember, communications within the data center, you're not charged for bandwidth. So between maybe I'm running compute and storage in the same data center, southern US, for example, then as they communicate with each other, there's no bandwidth charges there. So with this simple scenario, I expect to spend about $13,000 a year on that. Now I can go over to the migration costs. I can put in what I charge for hosting today, my expenses for the facility. $200 a year for hardware expenses is ridiculously low when you think about keeping backup hardware in place and stuff. Yes, sir. Yes. So you do want to set up affinity so that you're deploying your storage and your compute if you're using both to the same data center. So that was your first part of your question. But you mentioned content distribution. Do you mean like CDN and stuff like that? So CDN doesn't care where your origin data, which of the data centers your origin data is in. But if you're, for example, the bandwidth in the US and Europe is cheaper than the bandwidth in APAC, right, in Asia. So I would put your origin server in those places just so that part of the bandwidth is cheaper. The CDN side of the bandwidth between this cache server and the user, that charge does change based on which CDN server you're using, because again, Asia bandwidth is more expensive than North America or European bandwidth. Good question. I will show you our tool, which requires a degree in economics to use, which will give you a more sophisticated pricing model. So I think most companies spend more than $200 in hardware a year. And this is for repair operations on your current hardware. Maintenance, labor, definitely. Labor does not go away when you move to the cloud. You're just doing different things. Instead of fixing spinning disks, you're monitoring and managing the SLA and the environment and the resource and that sort of thing. So they think they're spending $2,000 a month. There is some cost of migrating my application to the cloud. They estimate $5,000 in 4 months to do that work. I've seen some apps migrate in a week if they are well architected or they're simpler web apps. I've seen others take 6 months or longer to do. So the monthly charges in the cloud are a little over $1,000, and they expect in 10 months then to have your break-even point with your ROI. So these are numbers that you might want to use a tool to sketch out what are things going to cost me, is it going to make sense to move this to the cloud, that sort of thing. And remember, not everything should move into the cloud, right? Some parts should move into the cloud. Maybe some parts should stay on premises. Some parts will be on the phone, laptops, in a hosted environment, that sort of thing. And our goal with Windows Azure and Windows Server and Hyper-V and all of that is to make it a very integrated platform so you can run a hybrid architecture, that I can run my application here and put just my storage in the cloud. If I have a very public-facing website, moving my storage in the cloud will give my users better performance on that storage and probably reduce my costs on shipping that storage and managing it. If I flip over here, if you go to Microsoft.com/Windows Azure and click on Offers, which will be here under the Buy column, you'll see right over here, Launch the TCO calculator. TCO stands for Total Cost of Ownership. So I have to accept the terms and conditions of that. It's going to ask me to fill out a little bit of profile about the type of company I am. So we're going to all start a company right now, and we need a name for that company. This is being recorded. So out of the 10,000 people in this room, people watching the recording can't tell how many people are here, so there are 10,000 people here. We need a name for our company. Does anyone have a name for our company? This is the interactive portion of the show. Feel free to yell it out. I know it's Thursday afternoon. Fluffy Kitten Weapons. Fluffy Kitten Weapons, Inc. Some marketing guy is going to see that and go, what the? All right, so I'm just going to run it. We are in the banking industry, of course. And we'll just do Asia Pacific. And we're web applications. It's a blog platform. And it's net new development, we'll say. Blah, large. I'm just filling in junk at this point. This isn't the important part. Okay. Click the next button down below. And basically, this is going to walk us, just like the other tool, but it's going to be more sophisticated. You can see here, they have already said, well, based on the answers you just gave, we think you're going to have 18 instances. And the average use hours per day on those means, so 24 says we're going to run those 18 instances full time. So let's put in 12 here. That means on average, these 18 servers will run half a day. That means I might be running 12 servers full time and 6 servers half time. There might be some mixture in there. And again, people, when you think from data center applications, I think of a static load. I have my app running on 4 servers. It's going to run year round. But a lot of companies are using Windows Azure, are using cloud computing for a shorter time length. So I might have a marketing campaign tied to Facebook and a social campaign, and I'm only going to do it for the summer. Like Coke and Pepsi, they do the drink a lot of this stuff, and you get points, and you redeem the points, and at the end of the summer, you can get prizes that say Coke and Pepsi on it. Well, not both Coke and Pepsi, but you know what I mean. And, a satchel or a shirt or a hat. And at the end of that campaign, they shut it all down. So instead of lasting 365 days the whole year, maybe we only use it for 90 days. We're only going to use it for that one campaign. It's a great use for cloud computing that enterprises might be very excited about. So then I can go through here and say, well, this is how many hours they figured out. How much storage am I going to be using? My transactions. Well, okay, I'm paying 12 cents an hour. That's going to cost me, my servers, roughly $2,300 a year. And so you can go through this tool, my SQL Azure databases, the use of that fabric, the bandwidth, all of that, and calculate that out a little more precisely than what the simpler tool I just showed you from Nudesic does. And we can go, it'll walk through this more, and this is where it gets all accounting and financy on you. But you can continue to go through this tool and kind of work out all those scenarios and build some reports that'll help you do some of the product planning and comparisons on your project. Any questions on ROI? So I just showed you the ROI tool on windowsazure.com. Okay, so we're going to use a lot of storage in the cloud, and we don't ship out of the box a tool to let you work with that storage. There's an API and there's a REST service and all of that, and you can, in your code, read and write and work with that storage. But if I just need to upload 1,000 pictures of my product catalog before I get started, we don't have a tool out of the box to do that. Today, the Windows Azure tools for Visual Studio give me a read and write capability on blobs and tables, not queues, but I need something else to use. So one tool that a lot of people use is a company called Clumsy Leaf, and they ship a product called Cloud Explorer. Now they have 3 products, one for blobs, one for queues, and one for tables. The one for managing blobs, which again is like a file system in the cloud, that is free, and that's the one I'm going to show you today. It's a rich desktop client. I can connect to multiple storage accounts in the cloud over across multiple subscriptions. It's updated quite a bit. I can copy, move, delete, rename files, so I'm used to doing that in Windows Explorer. On my local disk, I'll be able to do that in the cloud. It supports something called string root, and if I create a container called string root, it's basically an invisible container. So if you think of a normal blob container, we're going to have a storage account name. So let's say we had what? Fluffy Kitten Weapons was the name of our company. So we're going to have weapon product images .blob.core.windows.net / the container name, so product images / image.jpg. Well, instead of calling my container product images, if I call it string root, that layer of the URL will disappear, and it will be fluffy kitten weapon storage.blob.core.windows.net / image1.jpg. So that's not all tools support that string root capability that we have in blob storage. The best part about it is when I'm trying to upload things to the cloud, I can, especially with blobs, I can do that in parallel. I can break them into blocks. I can upload those blocks in parallel, commit them on the cloud side, and that helps me resume an upload that has been complicated or ruined in some way. So I can resume and pick up and finish what I'm doing. I have a lot of I have a company that I work with. They upload gigs and gigs and gigs of video, and then they do video processing on those files to turn them into from 2D two-dimensional video into three-dimensional models of the space you shot with the video. So they really like the auto-resume capabilities that a tool like this would give them. And so developers are tempted to just build their own tool, right? I can build this better in a weekend, but it's free. Can you build it better than free? Right? And just use it and get going and that sort of thing. So, and the other thing it supports is shared access signatures. This is a way that we can create very fine-grained permissions into my storage. So I can give someone the ability to read and write to my storage or just that particular file for 10 minutes or a day or something like that. So imagine they bought a book, and I'm going to give them a special URL to download that book, a read-only URL, and they have 30 minutes to download the book, that sort of thing. I would use that shared access signatures to do that. So the tool provides a capability to do that by hand instead of doing that in code. So we are going to, this is what it looks like, but I'm going to show you here. So load up Clumsy Leaf. Try to do the zoom in so you can see. Again, I have access to my local drives, and I have a folder here called Brian H. Prince Pictures. I'm going to open that up. You can see I have a container called string root. That would be a secret container. I have one called family. In here I have a ton of folders. Here's where I'll zoom out. I have a ton of folders. One of these is when I went to Prague to do some boot camps in Prague, and I can then easily browse and view my pictures. It's going to download it over our wicked awesome fast network here. Actually, I was told I think TechEd has 600 megabits per second bandwidth for the attendees here at the conference center. So there's a picture of Prague. So it's easy to drag and drop files in and out of this container. Let me bring up an Explorer window here. For example, I have a document here called just prep, and I'm just going to drag that into that container, and it will start. See, it just did it real quick. It will start and upload that, and you can see it's already in the cloud. Those are all the steps I have to do to start this demo. Then I can rename that in here if I want to. So prep steps for my demo.docx. That'll take a second and execute that. I screwed up my extension. And then I can easily delete that file as well. So very easy application to get in and around and work with storage. Now, the free version only works for blob storage. You can buy their table and queue tools. Another tool that I use quite often is from a company, a small ISV named Cerebrata, and I'll have their link up in a second, cerebrata.com. And I use their Cloud Storage Studio quite often. It does blobs, queues, and tables all together. For example, and over here, I've connected, I run a program at Microsoft called Windows Azure Bootcamp. We have a website, windowsazurebootcamp.com. Doesn't get a lot of traffic, maybe a couple thousand hits a day. So I run that at a traditional shared hosting site for $5 a month, no big deal. But the storage I'm using out of Windows Azure, and I have our schedule of what boot camps are happening where around the world stored in Windows Azure, and I manage it through this tool because I was too lazy to build an admin tool. So I have all that stored in a table, so I can open up my list of tables. I have one called the Azure Bootcamp Schedule. I can open up that, and it will load that table. Tables are basically spreadsheets on steroids. And I can see here we have one. Anyone from Cleveland? No? So there's one in Cleveland. We can load that up. I can edit it through this interface. I can see here it was on January 19th in 2011. January is a great time to be in Cleveland, by the way, if you like a lot of snow. And they get the snow effect. All of that kind of stuff was in there, and I can edit and delete. I can download. I can export to XML. I can import data. Gives me a tool to kind of work with that easily at a low level, kind of like using SQL Server Management Studio on my data. This will also manage queues. I don't have any queues running in that storage account, and containers, just like Clumsy Beef will. So I can go in there and look at trainer headshots. Have about a bunch of blobs here. We'll bring up my picture. There's my picture. Does that look like me? The t-shirt says backwards compatible. So now, where's going to go with this? They have a new feature that they're releasing that they were telling me about called, I'm going to screw up the name of the feature and I apologize, but it's the Page Blob Explorer. So a lot of people, we have the blobs can be block or page-based. If it's page-based, you could basically create a VHD in storage. And you can mount that in your Windows Azure servers as a virtual hard drive, as a drive. It'll get a drive letter, and my code can read and write to that like a normal drive. We call that the Windows Azure drive. This VHD I can then download to my desktop and mount as a local drive and work on it locally. And their Page Blob Explorer will help you upload and download these page-based blobs, and it will even download the VHD very intelligently. It doesn't download the whole blob, only the parts that it needs, and then mounts it as a drive locally so you can explore it and then re-upload it again. So it's a great, great feature to be able to work with VHDs like that. I believe this app, I think it comes up in the slides, costs $65 or something like that. So if you could build this in less than an hour, then do that. Otherwise, I would just go buy it, tell you the truth. Yes, sir?
All those transactions cost money because data is moving in and out.
Yes.
Do any of these tools log some of that information so that you can correlate later your bill?
So the question is, all of these storage transactions that these apps are causing, getting the list of pictures in my folder and that sort of thing definitely cost money. And do any of them do any logging around that? Not that I'm aware of, but I would use the system diagnostics tool, and I would be able to track those transactions that way probably, right? The diagnostics API. Or actually what you could do is the last tool, I'm not going to tell you which one it is yet, the last tool we show will track all that traffic, and you would be able to use that to figure out how much it's costing. Yep. Any other questions? Okay. So we just did that demo. Now we ship a set of very low-level fundamental PowerShell tools. PowerShell, I think, is the second most important thing a developer should know how to use in the .NET world. IT pros tend to be very good at PowerShell. We have kind of a rule at Microsoft: if you can do it in the GUI, let's say managing Exchange Server, managing SharePoint, and all of that stuff, you have to also be able to do it through PowerShell. And we do the same thing. So PowerShell calls the PowerShell commandlets that we ship call the REST API for that the service management API. That's the same API the portal is built on. It's the same API that Visual Studio uses. And what Sarah Brada has done is built a higher order of PowerShell commandlets on top of our commandlets. So for example, I have a very easy set of scripts that will back up and restore SQL Azure databases. SQL Azure today does not have a backup and restore feature. It'll allow me to back up and restore blob containers. Just because they're stored in triplicate in some data center somewhere doesn't mean that I don't need backup, right? There are three key things you need for data. High availability, we do that with 3 replicas of your data. Disaster recoverability, we do that by soon allowing you to store one of those 3 replicas in a distant Azure data center. And the third is true backup capabilities, because someday Bob out there will write some bad code and destroy half of your images or drop half of your customer table, right? And so that's what we need to protect against, is those logical errors, not the physical failures that happen. So we need some sort of backup capability. Sarah Brada ships these commandlets for about $70, and it will do, there's probably 100 more things that these do. I couldn't put all those bullets on the screen, because as we all know, bullets in PowerPoint kill. So, but they will help you very easily build out these scripts that will automate a lot of the management tasks that you need to do in the cloud. Deployments, teardowns, upgrades, backup and restores, those sort of things. Our commandlets that are free are on, actually you could just search for, of course you would use Bing. You could search for Windows Azure commandlets, and you'll find them on msdn.microsoft.com /Azure commandlets. And you could launch those and use those. Now, I said PowerShell was the second most important thing all .NET developers should know. Does anyone know what the first thing is? It's not my blog address. I know you're thinking that, but that's not it. It's Link. I think Link is the most important thing every developer in .NET should know, because it's so powerful and it touches every part of .NET. So Sarah Brada, I'm big fans of them. I'm sorry, this is the third tool of theirs I'm showing, but they've done a very good job building a lot of these things out. They have a diagnostics tool that will help you manage your diagnostics. So we have this very well, I'm actually very pleased with the API on the diagnostics side of things, and I can, using code within my application, create my diagnostics profile, and I can do that from outside my application. And that's great for a developer. But if I'm managing the environment, if I'm an IT pro and that sort of thing, I don't want to have to write and deploy code just to change what diagnostics I'm tracking. I want to be able to track diagnostics without impacting the code that I have deployed. So using a tool like Sarah Brada, they build on our diagnostics API, and it's a tool that will allow you to look at your diagnostics, change what you're tracking and what you're gathering, how often you're tracking and gathering it, and shipping it to storage, and it'll even graph it out for you and make it real easy. That way at runtime I can make changes and do those sort of things, whether it's a scheduled transfer or an on-demand transfer. Again, this tool is at sarabrata.com, and it's $70. This is what it looks like. I'm going to show you a demo live in a second, but this is basically what it looks like. On the left, I'm going to pick my subscription, the application that I have deployed. In this case, there's a pop-up configuring what performance counters we're going to track. So we're tracking percent of processor time every 600 seconds, available megabytes of memory every 600 seconds, and the total requests per second across the application servers every 600 seconds. Those are then transferred, you can see here in the middle, to blob storage. Actually, perf counters are going to go to table storage every 10 minutes. So I can make that change, hit save, it'll push that configuration out to my application, and I'll start gathering diagnostics on that level. And then I could look at a graph of those perf counters to see how my memory and CPU is happening. So remember I was telling you about how you might manually monitor the diagnostics of your engine to see how your app inhales and exhales. This would be one way to do that. So real quick, just to go and show what this, I'm going to close Clumsy Leaf. And here's my diagnostics monitor. And you can, just really quickly, I have been polling the average total CPU processor time across my instances. And you can see this spike over time, over the last couple hours of tracking that CPU as I was running that little tool to put some simple load on my application. I can do lots of stuff in here, manage my trace logs, my infrastructure logs, my IS logs, crash dumps, all of that. I can go in and force an on-demand transfer if I wanted to. That's when I don't want to wait for the scheduled transfer to happen. Maybe I have a server going down I want to deal with. And so I can drill into each one of those and change their configuration and manage all of that. Has anyone worked with the Diagnostics API directly? It's easy to work with, but the namespaces and class names are literally this long, so the code looks very complicated. So when your boss comes over, just bring up that code, and it look like you're really busy. But it's actually simple to work with. Okay, now there is something that we ship. It's not. I don't believe it's supported as an official product. It's more of a sample, if you will, called the Windows Azure MMC Snap-in. So the Microsoft Management Console, we have a Windows Azure Snap-in. That'll actually, it's free. It will give you simple management on your storage, give you simple management on your diagnostics, and so on. It's not as sophisticated as these commercial tools. Just showed you that. Okay, how many are using their MSDN subscriptions for Windows Azure? How many of you are paranoid that you're going to go over that free limit and burn your credit card? Great way to make some frequent flyer miles, by the way. So developers worry about that. When we give you a free allocation of developer time with MSDN or with the introductory pack, even if you don't have MSDN, you can get free time in the cloud with the introductory pack. People are worried that they're going to go over their free amount. You have to have a credit card enrolled, because when you do go over your free amount, we're going to charge you for that because you're using it. And the intention of the MSDN free benefits is that I'll build my app, I'm developing locally, I'll deploy 4 servers to the cloud, do some demos or testing or something like that, and shut that down. For example, no one's doing testing at night. There's no reason to leave those up and running. So write a script, schedule it at 6 p.m., because all developers, don't work overtime or anything. So when you're done for the day, that schedule will kick in and shut those servers off and bring them back online in the morning or that sort of thing. But if you're still worried about going over your quota, a friend of mine, Mike Wood, who's the Windows Azure MVP of the year, by the way, congratulations to Michael. He's out of Kentucky. He's out of, it's near Cincinnati, Ohio. He's on the Kentucky side. And this will run on your computer. This is open source, so you can see how he wrote it on Codeplex. It will run on your desktop, and it will monitor your environment, and it will remind you when you leave stuff up and running. You can say, hey, poll every hour and remind me. And a little pop-up window will happen, and I think I have a sample screenshot here. So here it says, gray box alert. You have one deployment in this top screenshot. The middle screenshot, he's clicking on that icon, and he's saying kill active deployment. And you can see here, he needs to reword it. His name is Mike Wood, so his alias is Mike Woe. Kill Mike Wood, the guestbook sample. So he thinks that he might want to reorganize that so it doesn't become self-aware and actually kill Mike Wood. And down bottom, it's showing that it's sending the command to stop that out. So you can leave this running on your desktop and not worry that you're going to leave stuff up and running and burn your allocation before you've used it. It's a great way to protect yourself against that. Graybox with an E. I always spell gray with an A for some reason, but he spelled it with an E. Graybox.codeplex.com. It's open source. It would be awesome if you grab that, maybe add a couple lines of code, try to add a feature or two. That would be awesome. Very simple to deploy. We make everyone use it in our Windows Azure boot camps. I used to use it because I used to have to pay for my Windows Azure time, even though I'm an evangelist, until marketing started paying for it. Now that someone else is paying for it, I just leave servers up all the time. But when I had to pay for it, I used Graybox quite aggressively. Any questions on free allocation with MSDN or something like that? Remember I said we had cards in the back for the Windows Azure Pass where there's no credit card involved, but you will get 30 days free to try that out. So I don't have Graybox configured for, it's not working on this network for some reason, but you can see the icon way down there. And does anyone know why it's called Graybox, why the icon is a gray box like that? Does anyone remember? Do you remember why?
When you do your deployment, your box turns from gray to blue.
Yeah, in the old portal. In the old portal, an empty service account would have a gray box. It was empty, it was sad, it didn't have any code. And when you put code in it and deployed an application, it would turn blue and happy. And in the new portal, you'll see these tiny little blue icons. Actually, I can show you right now. Right here, you see these little blue icons right there. I have code deployed, so I have a blue, happy Jello cube, and it's happily running. We don't have gray cubes anymore in the interface. So the old saying was people were confused if they were going to be billed or not when they have something running in the cloud. And the old saying was if the cube is gray, you're okay. And if the cube is blue, a bill is due. That doesn't work anymore because we don't have those cubes anymore. But that's still the rule of thumb. If you have code deployed, even if you've clicked stop, up here, for example, I can select this guy and click stop. Even if I click stop, that code is still on those servers. We can't let anyone else use those servers because they're dedicated to you, so we still have to charge you for them. We don't stop charging until you click the delete button over here. You have to stop it and then delete it. Then we will turn the servers off, clean them out, get all of your stuff off of them and all of that. They're destroyed because they're virtual servers. And then we'll stop billing you for it. Okay? You can keep the service account, so this Tina node here, but you would destroy the deployment itself. Any questions on managing that in the portal or otherwise? Okay. So how many people are migrating applications to the cloud versus building new ones? I was a consultant for 15 years, and it was great because I always worked on new applications. But in the real world, outside of consulting, most of the time, you're migrating and upgrading applications, brownfield development, they call it. And a lot of applications are built on SQL Server, right? So a friend of mine built the SQL Azure Migration Wizard, and this is an open source tool, sqlazureMW.codeplex.com. It's free. Again, something that you could contribute code to if you're looking to expand your career a little bit. And I will run this tool against my SQL Server database. It will analyze the schema, tell me what parts of that schema are not compatible with SQL Azure. For example, SQL Azure requires that tables have a clustered index. And some tables in your normal local database may not have a clustered index, and so it will pick that out, and it will tell you about it. And it will say, hey, man, you're not compatible here, and it will give you the option to rewrite that schema to fix the problems. It might be column types that aren't supported. Maybe you are calling the SQL CLR from within a stored proc. It'll call that out. So it'll really tell you how compatible your database is with the cloud. So it will rewrite that schema for you. And if you want, it will then execute that schema against a cloud SQL Azure database, build the database, and if you want, it will migrate all of the data for you using BCP under the covers, a bulk copy. And so it really makes it easy to kind of migrate this stuff up into the cloud. It's not perfect. It is rules-based. You can tweak those rules. I know a lot of DBAs are very fussy about how their scripts are written and laid out and what terms they use and so on, because they have it's just like how developers are fussy on how their code is laid out. And so because it's rules-based, they can tune those rules and control how those scripts are emitted, the layouts and the tokens that you use in there. That will move all your data over and take care of all of that for you. Now, I've heard that some very sophisticated databases this tool won't help you too much with. It is an open source package. I believe Redgate, who's here in the expo hall, I love Redgate. I've used their stuff for a long, long time. Are you with Redgate? Awesome! Let the record show there's a Redgate, with a red shirt on, by the way. You're not a Star Trek fan, are you? No, because you would know what that meant. But all the Star Trek people are laughing right now. They have a tool that does a very similar thing, and I've heard it's much more sophisticated. I haven't used it yet myself. Do you know what I'm talking about? Am I making this up? She's nodding her head yes. Okay. So, what's that? No, she says it's true, not that I'm making it up. Yeah, so if they go down to your booth, will you give them a free copy?
I can't say that.
No, she won't say that. maybe a trial copy. This is what it looks like, and actually I can actually migrate without analyzing. That's like when you just roll rough on the hood, you know. You can just let's just migrate. We don't care. You can do lots of. It's actually a very flexible tool, so you might run it against your database on a regular basis as you develop it locally to make sure that you're staying compliant with what SQL Azure is capable of doing. George Huey wrote this actually, and he ships upgrades to it to that rules base quite often. If you run into something it doesn't support, I'm sure he would welcome your help in updating it. Okay, giant lobster. I'm from Maine. You have to get a lobster in the slide deck at some point. Locad, like I said, is that company. Again, I think they're from France. They have several projects in CodePlex. The one I'm talking about is called locadcloud.codeplex.com. Again, it's free because it's open source. I believe Steve Ballmer said free as in puppy, but we won't go there. Their package actually does a lot of things. I didn't put all of the features it has on here. It's kind of a framework that you might pull into your application and leverage the components of it that you want, kind of like enterprise libraries. Anyone use enterprise library from Patterns and Practices? It's got like 900 things in there. You might only use 2 or 3 things. So for example, I can read and write to blob storage anything that I want. They provide a way to strongly type on top of that blob storage so that you're only storing Word documents or in that container, for example, that sort of thing. When I'm going to store things in table storage, so tables, each entity in a table has its own schema. It has its own properties. Every entity can have a different schema if you want. And there's a limit to the number of properties you can have. I believe it's 255. And there's a limit to the size of each property of the entity. What they have written is basically has turned Azure Table, Windows Azure Table, into an object store. So it serializes your object and just shoves it in a table as one entity, as one property on that entity. And then you deserialize it when you pull it out. So it's turned it into a true object database. The queue service, which I'll show you a sample of just as some code. How many people have worked with queues? Generally, you write an infinite loop on queues. While true, pull the queue, pull a message off the queue, do the work, delete the message. And you write these loops in your code. Generally, remember that worker process I had that was pulling the queue? I would do sort of that sort of thing. They have some code that will wrap that and create that for you. So they will just new up a service that monitors the queue on your behalf and calls events in your code when you get messages back. It's still polling behind the scenes, but it does some of the lifting for you, and that's nice. They have a fairly simple auto-scaling capability built in, and they have a task scheduler. Windows Azure does not have and SQL Azure doesn't have a task scheduler. So they have a task scheduler capability where you'll put jobs in there. Hey, every midnight I want it to go clean up dead session data in my web servers, for example. Those sort of tasks that you might run on a regular basis, and they have a capability in there to do that. So you can see here I have some code, and we're going to pull a message off of the queue, and we know that it's going to be a double because it's a strongly typed queue because of we're using locad will allow me to strongly type a queue. Normally you can put anything in the queue you want. And we're going to get that double X out of the message, and it's going to square it, and then it's going to put it back in another queue called Pong. So how do we tell this service to pull off doubles? Well, we inherited from queue service, and we passed in type T of double. And we decorated our class with this metadata here, queue service settings, auto start true. So auto start polling this queue. and the queue I want you to monitor is named ping. And elsewhere, I have configuration that knows which storage account to connect to. So it's going to start monitoring, and I can put in there how often to monitor and things like that. But it'll start monitoring this ping queue automatically, pulling messages off of them, routing them to this class, and executing that start method. And it will allow me to process those messages accordingly. So it gives me it kind of abstracts me away a little bit from the infrastructure needed to read and write to that queue, so that I don't have those entanglements in my code itself, right? So I have some clean separation there. There's a ton of things that their package does, and you should really check it out. Okay, this is probably my favorite tool. This might break my not from Microsoft rule, because it's from Nate Totten, who's an evangelist at Microsoft, but as a company, we don't ship it. It's just something that him and Steve Marks cooked up one day. I don't know where they were or what they were doing while they cooked it up, but they did. So here's the thing. So with web roles, since SDK 1.3 shipped, gosh, I think a year ago at TechEd in New Orleans. Anyone go to TechEd New Orleans? A lot hotter last year than it was this year, I'll tell you that. And I can run multiple web applications now per web role, but they are part of the same deployment package. So let's say I have web app A, B, and C in that web role, because they don't need a lot of horse processing, so I'm going to combine them together. But now when I want to update application B, I have to redeploy all of them together. And I may not want to redeploy A and C and have that downtime when I just want to update B. So what he's done is he has written a web role template called the multi-tenant web role. You deploy it to a web role instance, multiple instances if you want. It will monitor a blob container that you give it, and then you will deploy a web application in a zip file to that container. It will pick it up from the container and deploy it to IIS on your web role instances. And as you copy files in or remove files from that container, it will synchronize. If the instances go down, a new one will come on and it will resynchronize from that container. So it's always working. The protocol is actually HTTP. I just noticed that typo. We did not create a new protocol. Sorry, I didn't mean to get your hopes up. So it's azuretoolkit.codeplex.com, whack releases, whack view 62330. Why is there a weird URL? Because it's part of something called the Windows Azure Toolkit, which has a bunch of other stuff in there as well. It's kind of like the LOCAD set where there's a ton of tools in there that you're going to want to look at. But I just wanted to highlight the multi-tenant web role. So I can't build a PowerPoint without doing some funky animation. So we have our developer down here with their laptop, and she builds a website. She builds this zip file, and she deploys it up into that blob storage. Now we have a role instance monitoring that blob storage, and it will notice that new file, pull it in, wire it up to IIS, and do a little dance because it has a new website to host. Because web servers are happy when they have stuff to host. And so that's how simple it is. And if I go and delete that blob file, it will remove it from IIS and clean everything up. Now it does this with host headers. So I'm going to name my file with the host header that I want it to use in IIS, and then I'm going to go configure DNS to use that host header to point to my web role instances in Azure. So let me show you how that works. I've already deployed two of them, and they were generic web applications. So I did site1.brianhprince.com. This is running in Windows Azure, and that's the same. So that's site 1. And if I go to site2.brianhprince.com, go ahead and do that on your fancy iPad over there, and it will come back. And I picked ugly green for that site, so we can determine between the two. Now to show you how I deployed those, let me open up Cloud Storage Studio. Open up the storage account that was going in, and I'll just show you what I'm doing here. I had a container. I have a storage account called Tina MT for TechEd North America multi-tenant. In there, I have a container called Sites. I've wired up this multi-tenant instance to monitor this container. And in there, I have two zip files, site1.brianhprince.com.zip and site2.brianhprince.com. I'll show you what are in those files here. I have them locally. And we're going to build a new one. So inside Site 1, I have the certificate. So if I'm using SSL, I would put the certificate in this zip file. And in the site folder is just the contents of the plain old vanilla ASP.NET MVC application, right? We could change this CSS and oh, let's do that. Would be fun. I don't know if that'll work. I'm going way off script here, but we're going to be fun here. So we are going to open the CSS. Can I edit it in here? Let's say background color. Let's do 000. I don't know if I can save to the zip. Now I'm going to have to build a new zip. We're going to build a new app anyway, so didn't mean to get your hopes up. Let's go into Studio. We're going to do new project. I am going to pick web, ASP.NET Web Application, and Visual Studio in C#. We are going to make one on Ninja unicorns. Because I've been all about unicorns lately, and I just thought Ninja unicorns would be even better. So this is a very plain vanilla site. Just to prove that we're doing this live, someone give me something to put in the H2. Anyone at all? We're doing, awesome, like I wouldn't have predicted that. Okay, so we're doing this live. Ninja unicorns for the win. And you can't have, oh, you know what? And we're going to start another new company. That's 2 new companies in this one session alone, right? We're doing Ninjas as a service. That is the new, rocking, awesome part of the cloud. And then we need a picture, and I downloaded from Bing Image Search because on Flickr I couldn't find anything good. I will, I have an image on my desk, in my folder here. And it is of a robot unicorn. We'll just draw, oh, I have to do add, I'm sorry. Add existing item. We will drag that into here. We will save this. We will configure, now we're going to configure our web publishing settings. So all we need to do for web publish is choose a file system. We're going to do this locally. We're going to go to a local folder in here called publish. Do you really want to create this folder? Now we're going to publish. So you guys probably do that on a regular basis. I have a website about Ninja unicorns, which probably happens all the time. I'm going to publish that locally. I'm going to go into my folder where I put, here's my publish, so there's the website, there's the robot unicorn site, just so you know it. I need to put this in a zip file, so I'm going to do, need to put all of this into a zip file, send to compressed file, named bin.zip. We're going to rename this ninja unicorn.brianhprince.com.zip. We're going to take that in our storage client studio, upload it to that container. Let's hope I did that right. I think I missed one step. Let me double check here. Yeah, I have to create a folder called site. I'm sorry. Delete that. Create a folder called site. Put everything in there except itself. That's not what I intended, Mr. Windows. There we go. We will send that to a zip file. Name that ninja unicorn.brianhprince.com.zip. Now, before I drag that up there, let's test to make sure I haven't done this ahead of time. So, ninjaunicorn.brianhprince.com, access denied. Reminds me of an old commercial. Okay. Drag that up there. Sarah Broad is going to upload it for me. Bingo. It's up there. Now, this is going to take a second for our web roll to notice it. So we'll just do what everyone else does, is hit F5 100 times. Is anyone hitting that site now? No one? Okay. We'll give it a second. We'll move on, and we will come back, and I'll show you that done. Ninja, for the, not for my site, but for where this is coming from? Yeah, it's really long. Just go to azuretoolkit.codeplex.com. There will be a link on that page for the multi-tenant web role. Okay? The 8th tool is the Windows Azure Migration Scanner. This is fairly new, WAMS. It's basically FXCOP for Windows Azure. So you're going to take it, you're going to point it at an existing application. It will scan it and look for assemblies and things that are going to cause trouble in migrating over to Windows Azure. So this is what it's going to look like. I'm going to point it at the directory I want it to scan. It will use a set of rules. We're constantly updating these rules. David Paulman worked on this tool with some of the people on my team. And there's the scanning interface. There's some fancy WPF going on. And then this is the results. So you can see on the top here, we're using SQL Azure File Stream. We don't support the file stream column type in SQL Azure. Lower down, you can see we're using the mail message. You can see halfway through down the SMTP news namespace. We don't support that out of the box. You might have to figure that out, that sort of thing, ahead of time. So that scanner will go through and tell you all the things you're going to need to look at when you're migrating your app. And the last tool that you need to use, and you're probably already using as a web developer, is Fiddler. So fiddler2.com will run in your local desk, and will just watch all of the HTTP traffic going around. So I've had that running, actually. And where did I do with it here? Oh, we can reload it again. And it's going to be watching all of that traffic. So as I go to this website and load it, let's come up our Ninja Unicorns. Yay! Robot Unicorn attack. And if we go back to Fiddler, you can see all of the HTTP that's going back and forth and inspect it and see what's going on. Because when we work with REST, you kind of need to see what's happening under the covers sometime. All right? Thanks for coming to such a late session at TechEd. Don't forget, let me flip over to the results. And don't forget to do your surveys and try to win. Has anyone figured out, let me show, what is that thing in the middle there? Are those USB-powered defibrillation pads? Has anyone figured out what that is yet? So fill out your surveys, win some prizes, have fun at the rest of TechEd, and I'll see you at the party tonight. Thanks for coming.